Hey guys, welcome back. And in this video, we're talking about generators in Python. I'm really excited for this section because we're going to talk about some more advanced stuff. And generators are one of these topics in Python that a lot of courses don't even mention, but they are essential for performance and also because the async development in Python, the asynchronous development that we're going to be learning later on, is built upon these generators. When you understand generators, a lot of things in Python start becoming a lot clearer. So what is a generator? A generator in Python is a function, but it's a special function. It's a function that remembers the state it's in between executions. So you can run the function multiple times and it will remember what it did the last time that you ran it. So that sounds pretty weird. Let me explain with an example. Imagine you wanted to build a list of 100 numbers. Very straightforward. You want to get a new list with numbers from 0 to 99, not including 100. So you could make a function like this one, obviously not using range and so forth, you know range. But let's not use range. Instead, let's build a list from scratch. How would you do it? A good way to do it would be to start with an empty list. Say, call it nums and make it equal to an empty list. And also start with an index equal to 0. Then while I is less than 100, say nums.append I. So you're going to append 0 at the start, then you're going to increment I by 1, which is going to make it into 1. You're going to append 1, repeat, append 2, then 3, and so forth, until you get to 99. And at the end of this function, return nums, which is your list of numbers. If we do print 100 numbers and we run that, we can see that it contains here our list of 100 numbers. Of course, we could use list comprehension for this. We could use the range function. But for now, let's assume this is a cool way of doing it, because what I'm really explaining is essentially how the range function works on the inside. So we construct a list, fill it with the first 100 numbers, and then return them. Now we have 100 numbers in a list. This entire list is in your computer's memory stored as this return value of the function. Now, 100 numbers is not very big, it's quite a small amount of space. But let's say we wanted to store 10 million. Million is like 100 numbers, but it would be something like 1,000,000 numbers. You would generate a list of 1,000,000 numbers and store it in this variable. That goes into your computer's memory, and it's presumably a bigger amount of memory that it's taken because each one of these numbers is taking up a small amount of your computer's memory. If you wanted 10 million numbers, then it is bigger, and so forth. Now, having 10 million numbers, not a great example, but just imagine you have a very long list of something. For example, these are often used in calculating prime numbers and in big data and things like that. You maybe sometimes want big lists of things. So a generator is used to circumvent this problem, because the assumption is you don't need 100 numbers all at once. What you need is 0 so that you can do something with it, and then 1 so that you can do something with it, and then 2 so you can do something with it. For example, with this 100 numbers, we could then go and multiply them all by 2 and store them in another list. How would you do that? You'd do something like list comprehension, x times 2 for x in 100 numbers. What you're doing here is you're using this list to iterate over it and multiply each number by 2. Let's think that this multiplication by 2 is an operation that we want to do in these numbers in order to calculate something.